Hello students, I Mrs. Madhavi Mhatre welcome you all in the next lecture of Mathematics 1. I hope all of you are doing well at home. We are studying chapter number 4, Ratio and Proportion. In this chapter, we have completed the topic ratio, then properties of ratio, operations on equal ratios, that is all the 5 properties. And then in the previous lecture, we have studied theorem on equal ratios or theorem of equal ratios. And based on that, we have seen solved examples also. And then we started with practice set 4.4. And in that, the last question is left out, question number 4. So let's go ahead in practice set 4.4. So all of you please be ready with your textbook, your notebook and pen, and write the answers along with me so that you will understand them better. Okay, so practice set 4.4, all of you open your textbooks and there we are solving question number 4. So here question number 1 and 2, they are exactly similar. I am solving question number 1 for you. Question number 2 you will solve as homework by using the same steps you are going to solve it. Okay, now as I have said, these type of questions are present in practice set 4.3 also, where we are using the properties of equal ratios. That means there we are using alternando, invertendo, componendo, dividendo, componendo, dividendo, etc. depending upon the type of question. Okay, the same type of questions these are, but now we are going to solve them by using theorem on equal ratios or theorem of equal ratios. As I have said, in exam you can go for any method which you like. Okay, so first one now here, see, 16x square minus 20x plus 9 divided by 8x square plus 12x plus 21 is equal to 4x minus 5 upon 2x plus 3. And the question is what? Solve. Okay, that means you have to find value of x. So what you're going to do is here, first of all, take the given ratio as x. The given ratio I'm sorry, not as x, not as k. So we will take the given two ratios as k. We will name them as k and we will number it as 1 because we need to use this statement afterwards. So 16x square minus 20x plus 9 upon 8x square plus 12x plus 21 is equal to 4x minus 5 upon 2x plus 3 is equal to k. Now here we want to use theorem on equal ratios, and by using that we need to cancel some of the terms. Okay, but that means either we can add or we can subtract depending upon the situation of, okay, but here what we can observe is the terms are not same. So to make these terms same, we are going to multiply the second ratio by minus 4x. Why by minus 4x? Because see here, 16x square, if we divide by 4x, we are going to get 4x. We want to equate these two terms to the first two terms of the first ratio here. And then we are adding. So that is why we want opposite sign. So we are multiplying by minus 4x. Second ratio, we are multiplying by minus 4x in the numerator as well as in the denominator. Okay, you know that we can do it because afterwards when it is cancelled, the original ratio remains the same. So this is also equal to k. Now let's write down the answer. Minus 4x into 4x, we will get minus 16x square. And here minus 4x into minus 5, we will get plus 20x. Exactly opposite terms of these two terms. And here also we will get minus 8x square and minus 12x. The opposite terms we are going to get. Okay. And then we are using the theorem on equal ratios. That means we are adding numerators and we are adding denominators. Okay. So by the theorem of equal ratios, the new ratio, that is k, is equal to, see, add these two. Okay. So 16x square minus 20x plus 9. Multiplication of these two is minus 16x square, and here we are going to get plus 20x. Similarly, 8x square plus 12x plus 21 as it is the denominator of the first ratio, and the denominator of the second ratio is minus 8x square minus 12x. Okay. Now what you can observe here is the opposite terms are present, plus 16x square and minus 16x square. So we can cancel. Then minus 20x and plus 20x. Similarly, in denominator 8x square and minus 8x square plus 12x and minus 12x. Okay, so they got cancelled. And when they got cancelled here, we got the numbers which are left out, that is 9 upon 21, which we can reduce further to 3 upon 7. Now observe statement number 1 and statement number 2. See, this is also, two ratios are also equal to k, and the new ratio which we got by using the theorem on the equal ratios 3 upon 7, that is also equal to k. So from these two statements, we can say that this smaller ratio 4x minus 5 upon 2x plus 3 is equal to 3 upon 7. We can write these two equal ratios here. Okay, see, 4x minus 5 upon 2x plus 3, from the statement 1 we have written, and from statement 2 we have written 3 upon 7, because both of them denote the value of k. Now, if we cross multiply and solve them, we are going to get value of x. Okay. So, it is very easy if you use theorem on equal ratios. Here, if you want to use the properties of the equal ratios, then first of all, you have to go for alternando. Then you have to multiply both the ratios by 1 upon 4x, and then you have to go for dividendo. So, instead, you can use this theorem on equal ratios. Answers are going to be same. Okay. Now let's go for the cross multiplication here. I hope you must have completed writing. If not, then pause the video, complete, and then go further. Okay, so let's cross multiply. So see, 7 into 4x is 28x minus 35 you will get. 7 5s are. And here 3 2s are 6x. And here 3 3s are 9. Okay, so that will be our next step. See, 7 multiplied by 4x minus 5 and 3 multiplied by 2x plus 3. So 7 into 4x 28x, 7 into minus 5 minus 35, 2 into 2x into 3 6x, and 3 into 3 is 9. Now take the like terms together on one side. So this 6x we can shift to LHS. It will become minus 6x. We will get 28x minus 6x here. And this minus 35 if we shift here, then we will get 35 plus 9. So 28 minus 6, we will get 22x here in LHS, and 35 plus 9 is 44. So x is equal to 44 divided by 22, that is 2. So we got value of x as 2. So in this way we can solve it. By using the similar steps, you have to solve question number 2 as homework. For practice, you need to solve them. Okay. Now let's go ahead. Here we have completed practice set 4.4. Now let's go ahead towards the next topic. The next topic here is continued proportion. Previously, we have seen four numbers A, B, C, D. If we write them as A upon B is equal to C upon D, then we say that they are in proportion. Now we are going to discuss here continued proportion. So let's see what is continued proportion. Now here we are going to consider two equal ratios, but these two equal ratios are different here little bit. What you will find is the ratios are A upon B is equal to B upon C. See, the denominator of the first ratio and the numerator of the second ratio is same. This B is continued further. Okay. So in this case we can say that A, B, C are in continued proportion. Further, if we want to write next ratio, it will be C upon D. Then A, B, C, D are in continued proportion. Okay, that means here the denominator of the first ratio is continued as the numerator of the next ratio. So it is called as what? Continued proportion. Okay. Please write down all these important topics or points. Now here when we cross multiply, here we will get A into C is AC and B into B is B square. So if AC is equal to B square and if we divide both the sides by BC, then we are going to get this. Okay. So here if we say that A upon B is equal to B upon C, it is same as AC is equal to B square. Okay. So this also shows us the continued proportion. More information is what? When A, B, C are in continued proportion, the term which is in the middle, it is called as geometric mean or mean proportional of A and C. B is called as mean proportional or geometric mean of A and C when A, B, C are in continued proportion. Okay, so by using this information, we can write down some statements which mean uh, where the meaning of all those statements is same. Okay, so we are going to write 5 such statements and all those 5 statements have the same meaning. Okay, let's see them. So here we have written 5 different statements. First statement is A upon B is equal to B upon C. If we cross multiply, then we will get B square is equal to AC. So here we can say that A, B, C are in continued proportion. Then B is geometric mean of A and C. Then also we will get same meaning. Or the second word for geometric mean is mean proportional. B is mean proportional of A and C. So all these 5 statements give us or convey us the same meaning that A, B, C are in continued proportion. Square of the middle term is equal to the product of the remaining 2 terms. Okay, in that case now the middle term is called as geometric mean or mean proportional of remaining 2 extreme terms. Okay. So here, as I have said there, the geometric mean concept, we can add more ratios here. So this concept is generalized for the n number of ratios. So if we have A upon B is equal to B upon C is equal to C upon D is equal to D upon E is equal to E upon F. So all these are said to be in continued proportion. Here we have 6 numbers, but here we can have n number of numbers. But only thing is that see the denominator of the first ratio is continued as the numerator of the next ratio. So in that case it is called as continued proportion. So in this way we can have many numbers in continued proportion. Okay. But generally now we are going to study only for these 3 numbers here, that is A, B, C. So now let's see some solved examples from the textbook. Example number 1. If x is the geometric mean of 25 and 4, find the value of x. See, x is geometric mean of 25 and 4. That means what? 25, x and 4 are in continued proportion. X is the middle term and these two are the extreme terms. Try to understand this. How you will write? You will not write x 25 and 4. You will write 25, x and 4. X is the mean here. It is in between these two numbers. Okay. So when x is geometric mean of 25 and 4, we can write down that x square is equal to 25 into 4. Okay. So write down the first statement from the question that x is the geometric mean of 25 and 4 and therefore x square is equal to 25 into 4, that is 100, and from that x we will take as 10. Now here plus or minus 10 is not written. Please take a note of this. Why? Because 25 and 4 both are positive numbers. Okay, so the negative number cannot come in between these two numbers. Therefore, we have to think of only positive numbers. So not to take plus or minus here, only take plus. Okay. If we have both the minus signs here, then we are going to think about minus 10. Because in between two negative numbers, positive number cannot come, and in between two positive numbers, negative number cannot come. So we are not thinking of plus or minus, only we are thinking of plus, that is positive. Okay. So this is simple question of 1 mark. Second one, if 4a square b, 8ab square P are in continued proportion, then find the value of P. Okay, so these three numbers are in continued proportion. So see, this is mean proportional and these two are extreme terms. So square of these two is equal to multiplication of remaining two. Always write down the statement from the question first, that 4a square b, 8ab square and b are in continued proportion. Therefore, we can write them in the form of ratio like this, that 4a square b upon 8ab square is equal to 8ab square upon p. Or you can write down the middle term square, that is 8ab square the whole square is equal to 4a square b into p. Anyhow it will do. It is going to give us the same answer. Now we are doing cross multiplication here. So value of p we will get as 8ab square into 8ab square divided by 4a square b. Okay, so be careful now what we can do here, how we can do the cancellation. See here, 1 8 we can cancel with 4, so here we will get 2, the number 2 we will get. Okay, this a square will get cancelled with this a and this a. Also 1b will get cancelled with 1b, and finally then what we are left with, see, we are left with this 2 into 8, that is 16, and b square into b, that is b cube, and therefore value of p is 16b cube. Okay, so it is very easy to understand. This way you have to write down the continued proportion. First ratio, first term upon the second term, again the second term upon the third term. That way you will write, and then simply you have to cross multiply to get the answer. Okay, I hope you must have understood this example. Now let's go towards the next example. Which number should be subtracted from 7, 12 and 18 such that the resultant numbers are in continued proportion? So here we are provided with three numbers, 7, 12 and 18, but they are not in continued proportion. They have given the condition that which number we should subtract from all these three, so that the resultant numbers, the numbers which we get after subtracting, they are in continued proportion. So this is unknown to us, and you know that whenever we have any unknown number, we take it as x. You can take it as k also, as I have said. Any alphabet can be used, but generally we are taking x. So what we will write is, let x be subtracted from 7, 12 and 18 such that resultant numbers are in continued proportion. As I have told you so many times, always write down the first statement from the question as it is. Now in place of which you will write down let x, in place of which number you will write down x, and the remaining statement is as it is. Now when we subtract x from 7, we will get 7 minus x. Here we will get 12 minus x, and here we will get 18 minus x. So we can say that 7 minus x, 12 minus x and 18 minus x are in continued proportion. So when they are in continued proportion, we can write down that the square of the middle term is equal to the product of remaining two terms. Okay, so 12 minus x the whole square is equal to 7 minus x into 18 minus x. So here you will use formula a minus b the whole square, that is a square minus 2ab plus b square. So 12 square is 144, minus 2 into 12 is 24, and 24 into x is 24x, and minus x square is plus x square. Now here you have to do the multiplication. You have to multiply each term by each term. So how it is done? See, 18 into 7, that is 126. Now see, this 7 into minus x is 7x, and minus x into 18 is minus 18x. So minus 7x and minus 18x, if we add, we will get minus 25x. Okay, or simply add these two numbers and write down the alphabet or the variable present there, that is x. And finally minus x into minus x is plus x square. Now what you can find here is x square is found on both the sides, and they are having the same sign, plus x and plus x. So you can cancel it. Okay, it can be cancelled from both the sides like this, and then you have to equate the terms. So what we can do is this minus 25 we can shift here, it will become plus 25, and 144 we can shift here. So see here, minus 24x plus 25x is equal to 126 minus 144, and therefore x is equal to 18. That means we need to subtract 18 from each of these number so that the resultant numbers are in continued proportion. Okay, so write down the final answer as statement that therefore if 18 is subtracted from 7, 12 and 18, the resultant numbers will be in continued proportion. Okay, so now this textual sum I am discussing because you know that they are equally important. They can be asked in exams also. So you also need to understand them. You try to solve them in your notebook without seeing as a practice. Okay, so that if it comes in exam, you can solve the sums. Okay, now let's go ahead. Here tally of that question is given, that we are subtracting minus 18 everywhere. So 7 minus x, that is 7 minus of minus 18, which will give us 25. Then 12 minus of minus 18, that will give us 30, because minus into minus is plus. And here 18 minus of minus 18, that will give us 36. So 30 square is 900, and 25 into 36 also 900. So see, we got the same product, and therefore we can say that they are in continued proportion. In exams, there is no need to write down tally. It is only given to make you understand. Now let's go ahead. Here now we are going next towards the K method. Here the K method is used to solve the examples which are based on equal ratios. K method is simple method. Okay, and here in this method every ratio is assumed as k. We assume the ratio as k, and then we are finding the new terms, and then we are using them, and the problem becomes more simpler because of the k method. Okay, so now let's see how to use the k method for solving the problems on ratios or and proportion. Now let us see some solved examples based on k method. If A upon B is equal to C upon D, then show that 5A minus 3C upon 5B minus 3D is equal to 7A minus 2C upon 7B minus 2D. Okay. Now, these are the two ratios, and we are going to use K method. That means we will assume these two ratios as K. Okay, so we will write down, let A upon B is equal to C upon D is equal to K, and therefore A is equal to BK. See, the cross multiplication is done. A is equal to BK and C is equal to DK. That means now here in the question, we will replace A by BK and C by DK, and then we will get the answer. So here in this case, since we find two sides, left hand side and right hand side, here these two sides we will evaluate separately. First we will solve only LHS. We will convert it to the simplest form. Then we will solve RHS. We will convert it to the simplest form. And then we will compare them. Okay. So see, substituting values of A and C in both the sides, here also and here also. So as I have said, only you will take LHS first. So LHS is equal to 5A minus 3C upon 5B minus 3D. So in place of A now you will write BK. Okay, see, A is replaced by BK and C is replaced by DK. In denominator we don't have A and C. So denominator is written as it is. Now what we can observe here is in the numerator K is constant or common. So that K is taken out and inside the bracket we are left out with 5B minus 3D. And now in this step denominator also we are writing in bracket so that it is possible for us to cancel this bracket. See, the equal bracket is seen here in numerator and denominator, so it is cancelled. So LHS we have simplified to K. Similarly for RHS, here A is replaced by BK and C is replaced by DK. Again K is taken out common, and while writing here, this is now there is mistake in textbook also. So here also it should be in bracket. Okay. So when we write down bracket like this, here this bracket we can cancel and then RHS also is simplified to K. So now we can observe here that LHS is K and RHS is also K. So we can write down LHS is equal to RHS and therefore 5A minus 3C upon 5B minus 3D is equal to 7A minus 2C upon 7B minus 2D. Okay, that means again you have to write down the thing which we want to prove. From the question we have to write down it. Okay. So see, because of K method the things have become more simpler. Okay. So that is why K method is better for us. Now let's see next solved example. If A, B, C are in continued proportion, then show that A plus B the whole square upon AB is equal to B plus C the whole square upon BC. Now see, A, B, C are in continued proportion. That means A upon B is equal to B upon C. That we will take as K now. See, A upon B is equal to B upon C. That we will take as K. Now when we will cross multiply here, we will get B is equal to CK and A is equal to BK. But in place of B, we can write CK. And therefore, value of A is CK square. In the previous case, A was BK and C was DK. But now here, A is in the form of K square, C. Because of this cross multiplication, B is equal to CK and A is equal to BK. But again, we are replacing by CK. So, CK into K, we are getting CK square. So, now in this particular example, now we will replace A by CK square and B by CK. Okay. So, let's take now LHS first. So these values we will substitute in LHS. So LHS is A plus B the whole square upon AB. Okay, now you will think that let's go for the expansion A square plus 2AB plus B square. But don't do that. Okay, instead taking out common is the better option. So write down value of A as CK square and value of B as CK inside the bracket and the whole square. Similarly, in denominator, A is CK square multiplied by B is CK. Now, here you will observe that inside the bracket, CK is common. Okay, so CK is taken out common and then K plus 1 is left out. But while writing, it is written separately CK square. So, C square, K square and K plus 1 the whole square. And in the denominator, C into C is C square and K square into K is K cube. Now see, again we can go for the cancellations. Here see, this C square and this C square is cancelled. Similarly, this K square and this 2 K's out of 3 are cancelled. So our answer is K plus 1 the whole square upon K. Similarly, let us solve the RHS. Now take RHS. So RHS is equal to B plus C the whole square. All the similar steps are done. B is replaced by CK. C is written as it is, both the places. So here also C is taken out common and it is written as C square. And then here we have K plus 1 the whole square. and the denominator c into c is c square into k. Again we can cancel the c square and c square and see the answer we got as k plus 1 the whole square upon k. See, both the sides are same, so we can write down LHS is equal to RHS. Therefore, the given thing is true, or both the sides are equal. So therefore we can write down a plus b the whole square upon ab is equal to b plus c the whole square upon bc. Okay, similarly you go through the remaining solved examples. Only I think one example is there, and then afterwards solve example number 4 and 5. They are under reduced syllabus. Okay, so please try to understand the solved examples. Now in the next lecture we will start with the practice set based on the K method. Okay, so revise all the things so that you can understand the practice set better. Okay students, so today I am stopping here. We will meet in next lecture. Till that, you stay home, stay safe, take care of yourself. Thank you students.